Quantum computing. For many, it sounds like science fiction, a strange, futuristic idea that's still decades away. But experts say this technology is very real, developing fast, and could transform our world in ways we're only beginning to imagine. Today, we dive into what quantum computing actually is, why it matters, and what problems it could help us solve. To guide us, we turn to Dr. David Sadek, Vice President of Research, Technology and Innovation at Thales, and a leading specialist in the field. So what exactly is quantum computing? Our current supercomputers, the most powerful machines we've built so far, operate on bits. These are strings of ones and zeros. A bit can be either 1 or 0, never both at once. That's the foundation of all modern computing. Quantum computers, however, work with qubits. And here's where things get fascinating. Thanks to the laws of quantum physics, a qubit can exist as both 1 and 0 at the same time, a phenomenon called superposition. It's often compared to Schrödinger's cat, which is both alive and dead until observed. Now imagine millions of qubits working together. Instead of testing solutions one by one, a quantum computer can explore countless possibilities simultaneously. The power grows exponentially. That means problems that would take traditional computers thousands of years might one day be cracked in minutes. This leads us to the concept of quantum supremacy. That's the moment when a quantum computer can solve a problem no classical computer could ever handle. Experts call this the next great paradigm shift, on par with the digital revolution that gave us the internet, smartphones, and modern AI. But right now, quantum computers are still at the prototype stage. The machines we have can only manage a small number of qubits. So the question is, how do we prepare for a revolution that hasn't fully arrived yet? Interestingly, the theory of quantum computing was laid out decades ago. In the 1980s, the first quantum algorithms were already being imagined. Take the Deutsch algorithm, which showed that quantum machines could one day outperform conventional ones. Then, in 1994, Shor's algorithm made headlines. Why? Because it could, at least in theory, break the encryption systems that keep our online banking and digital payments secure. This is why companies like Thales are already investing in developing quantum expertise today. They're training a new generation of algorithm developers who can think in quantum terms. It's not just about building new computers, it's about reshaping how we understand problem solving itself. So what technologies are driving this shift? They fall into two categories. First, the actual quantum machines. These rely on exotic phenomena like superconducting loops, ion traps, photon polarization, and cold atoms. They're still small scale, but real use cases are being tested. For example, the French startup Pascal, working with Thales, is using cold atom technology to explore new solutions for banking security. Second, there are quantum emulators. These run on traditional computers, but simulate the behavior of qubits. The catch? Simulating just a few qubits requires enormous computing power, so while they give us a taste of what's to come, they can't scale indefinitely. Think of it like practicing skiing on an artificial slope before the real snow arrives. It's not the full experience, but it prepares us for the future. What kinds of problems could quantum computing solve? Thales has outlined 6 main categories. 1. Combinatorial optimization, finding the best solution from countless possibilities, such as planning the routes of delivery trucks or satellites. 2. Solving complex equations with applications in physics and electromagnetism. 3. Monte Carlo simulations, useful in finance and risk analysis. 4. Quantum machine learning, merging AI with quantum power to improve pattern recognition and decision-making. 5. Cryptography testing, assessing whether current security systems can withstand quantum attacks. 6. Quantum simulation of matter, modeling molecules to discover new medicines or advanced materials. Already, Thales has been experimenting with these. One example, developing mission planning tools for satellite constellations. Coordinating the orbits and operations of multiple satellites creates a problem so complex that traditional computers struggle. But with quantum algorithms, the possibilities open up. They're also exploring applications in radar antenna design and cybersecurity, including detecting anomalies in data using quantum machine learning. So where does this leave us? Thales isn't aiming to build the world's first commercial quantum computer. Instead, their focus is on the ecosystem, developing the algorithms, the tools, and the practical applications that will make quantum computing usable on a wide scale, for both civil and military purposes. The journey won't be short. It may be years, perhaps decades, before we see large-scale, fully functional quantum computers. But the groundwork is already being laid, and when the breakthrough comes, it could reshape industries ranging from medicine to finance, cybersecurity to space exploration. Quantum computing is often called uncharted territory, a new landscape we're only just beginning to map. But if history is any guide, revolutions like this don't just change technology, they change society itself. For now, scientists, engineers, and companies like Thales are taking the first steps into this frontier. The quantum future isn't here yet, but it's closer than we think.